Welcome to 5-9, solving equations with rational numbers. That's exactly what our objective is to do. We have in the past solved equations. We now are introducing equations with rational numbers. Rational numbers include any number that can be written a over b, like a fraction. We can have negative and positive decimals, fractions, mixed numbers, whole numbers, natural numbers. We went over the number sets in a previous lesson. All right, my main objective is to find out what t is. And in order to do that, I must isolate my t. That means anything that is on the right hand of the equation, such as negative 8.5, must be moved to the left side. In order to cancel out that negative 8.5, I use the inverse, which is a positive 8.5. And knowing that equations are supposed to be equal, I must do the same thing on the other side. So I have plus 8.5. As you can see, t is now by itself. And then I take my calculator out and I add 2.1 and 8.5, and the answer is 10.6. I'm almost done. Second part of the directions that I must do is check my solution. Alright, to check your solution, it's basically plug and chug. You can see that I found out that t was equal to 10.6. I substitute t with 10.6. Now I'm just going to take my calculator and go 10.6 minus 8.5, and it says 2.1. Yep, it checks. In this slide, you can see that we have x plus 3 over 5 is equal to 2 over 3. Okay, so once again, my main objective is to isolate the x. That means anything that is on the left-hand side with the x must be removed and put to the right side. That means 3/5, positive 3/5, must be removed. So I'm going to use the inverse, meaning I'm going to take a negative 3/5. And that should cancel out. And because this is an equation, whatever I do on one side, I got to do the exact same thing to the other. Now I'm going to bring down the x. I'm going to bring down the equal sign, which is important to do. And then I'm going to take my calculator out, and I got 1 over 15. Just to review, you can see right here that I found out the LCD of 3 and 5 is 15. And in order for 3 to go to 15, I multiply 2/3 by 5, top and bottom, and I get 10 over 15. And 3/5, in order for the denominator to be 15, I got to multiply the 5 by 3. Whatever I do on the bottom, I do on the top, I get 9. And you can see that's 1 over 15. Alright, so the answer, once again, is 1 over 15. You can use your calculator, or if you need practice, there is how to do it by hand. On this slide, we have a different problem. It says solve negative 3 times y is equal to 1.5. I wrote my problem out, and my objective is still the same. I want to isolate my variable, that y. Now, I'm not going to add or subtract, because that's not what's happening on the left-hand side. I have a negative 3 times y. So I'm going to use the inverse of multiplication, which is division. And the number that I want to get rid of is not the y, but the 3, and that's actually a negative 3. Two negatives make a positive. 3 divided by 3 gives me 1y. I can leave the 1 there, or just leave it y. Now, this is an equation, so I have to do something equally on the other side. Since I divided, I must divide 1.5. And since I divided by a negative 3, I must divide 1.5 by negative 3. And when I take my calculator out, I notice that the answer is a negative 0.5. Sometimes you'll see it written this way, without the 1 in front of the y. Either answer will do, but I just want to make sure my solution is correct because they asked me to check it. We now have a plug and chug situation where in the original problem I had y, but now that I solved it, I found out the y to be a negative 0.5, and that's why I plugged it in. And I'm going to go ahead and use my calculator and multiply the -3 and the 0.5. Two negatives make a positive 1.5, and yes, that checks. On this slide, we have solve 5 is equal to 1/4 y, and we also have to check our solution. It's almost similar to the other one, but notice that we don't have a whole number in front of the y, or an integer. We actually have a fraction, and we're going to deal with it differently. Alright, I'm going to multiply by the reciprocal of 1/4, or the multiplicative inverse. If you remember, multiplicative inverse is some number that I'm going to multiply 1/4 by. That'll give me the answer of 1. So we're going to use the reciprocal, and you can see that this will cancel out with cross cancellation. We get 1 over 1, which is 1. So I'm going to be using 4 to get rid of that 1/4. And because it's a equation, whatever I do on one side, I have to do equally on the other. Okay, so watch this. The denominator cancels out with the 4. I'm left with 1y. And then over here I have 4 times 5, which is 20. And if you want, it's good practice, is to put the y first and then 20. So I assume my answer is 20, but I need to check it. Alright, I'm about to check it, which is a plug-and-chug situation, which I take the original equation and I substitute the answer I got, 20, for y. And I'm going to go ahead and do the work, or plug it into the calculator. I know 4 can go into 4 once, 4 can go into 25 times, so that gives me 5. It does check. Alright, on this slide, we have solve 2/3 x, or 2/3 times x is equal to 7. It almost looks similar to the previous slide, but we have our variable on the left-hand side this time. Alright, I'm not going to divide, I'm going to multiply. So I need to find the multiplicative inverse of 2/3. That is some number multiplied by 2/3, so that'll give me 1. What I'll do is I'll reciprocate, and you can see this cancels out and gives me 1. So 3 over 2 is what I want to multiply that fraction by, and whatever I do on one side, I do on the other. Alright, let's go ahead and cancel out our fractions. That gives me 1x. I'm going to go ahead and multiply 7 and 3 over 2. That gives me 21 over 2. Or, if you want to, you can make it a mixed number, which is 10 and a half. Now it's time to check my solution as it's asked in the directions. Alright, so I took the original equation, and whenever there's an x, I put in my answer. You can see that I left it as an improper fraction. I think it's much easier to work with it that way. You can see the cross cancellation much easier than with a mixed number. 2 cancels out, gives me 1s. 3 can go into 3 once. 3 can go into 21 7 times, so it equals to 7. It does check.